with the webinar. First of all, before going to talk on the technical topics, first of all, I would like to thank the management of Sharad Institute of Technology, College of Engineering. More particularly, I have to thank the chairman, vice chairman, executive director, the principal, Dr. Sanjay Ghosh sir, organizing committee members, teaching and non-teaching faculty members who are helping this STTP for conducting in a great manner. Also, I thank the participants from the Department of Triple and various departments in the own college and other colleges also. It is a very important day for us to learn about the energy conservation, energy management, energy best practices operated in the energy conservation activity through our through our auditing process. I think you in the morning session you learned more about energy conservation practices from two important veterans, Dr. Nagesh Kumar sir and Sri Jayas sir. Really, they are veterans because they did so many studies in energy conservation and energy auditing field, and I think you learned a lot of things, and still you are going to learn a lot of things from the next 4 or 5 days. Today, my topic is on energy conservation and electrical utility. Of course, it is a very electrical utility. We have a vast electrical utilities are available, but I am going to present one or two important case studies what we conducted, and we got some good results. And similarly, what are the approaches to be adopted for energy conservation in the electrical utility, and those things I am going to present. If you have any doubts, please kindly note the slide number, and we will discuss at the end of the sessions. This is a list of major electrical equipment in the industry. Of course, it is not available for all the industries, but most of the industries may have both electrical as well as mechanical equipment. Starting from electrical network or electrical system, electrical wiring system. From that, it is going to be an APFC panel and fixed capacitance. We have an electrical motors and drives, furnaces, lighting system, fan that applicable for both industrial and domestic fan. Blowers, HVAC system. There's a combination of if it is a small, it is going to be HVAC. Sometimes it is a chiller capacity, chiller, AHU, FCU. Then we have an RO plant, ETP plant, hot air generator. Again, that's a fuel dependent. Some of the points I represented here will have their own importance. For example, the hot air generator can be produced with the help of either it's an electrical type, or sometimes it is a wood-based hot air generators and something like. So different type of fuels can be used for generating the hot air. More particularly for tea industries or some other industries which require a direct or indirect heating applications. Then we have a cooling tower, and right side also we have some other equipment. Sometimes we can have an energy generation system like in solar photovoltaic and so solar thermal systems. Then boiler and allied system, steam generation, all those things are the part of the system. But before going to talk about the electrical energy conservation, we know that the efficiency offered by the system, starting from the generation to the end of the consumer, the efficiency is going to be keep on varying. Of course, this is the almost the latest data which we got from the Uday website. Generation efficiency is not mentioned here, as most of the people will know that the efficiency of the generation is going to be depends on what type of power plant, whether it is going to be an hydro power plant or thermal power plant. Of course, in India we are having an almost 65% the thermal power plant. The efficiency of the thermal power plant varies between 35 to 40%, or maximum of 45%. So put together, the cascaded efficiency is going to be around 87%. Or you can have a simple data of AT&T losses, including your commercial, agricultural, technical, and commercial losses, which is available in the website Uday, as most of the people will know that, and it is keep on updating regularly based on the discom company's updation. It is keep on updating. This is the current national average AT&T losses 23.05, which is taken 2 days back. I think, but slightly it is varying day to day. So I request the participants, after completing this webinar, please go and visit the website and check whether the present value of AT&C for the national values are changed or not. And from that, I just plotted the AT&C losses for different regions. As we know that we have 5 regions, the entire country, entire India was completely divided into 5 different regions based on the power system operation company. So the average is going to be 23.05, and most of the regions are higher. Only the southern regions are slightly lesser than the national average. And I also have a plot which will indicate the sector, the state-wise AT&C losses. Again, I told you it's 2 days back data, and you can just verify the website, which will give you current data if you have any updations. And most of the cases we have a higher value, and even if we have a lower value. And you know that the Uday scheme was coined by the government of India. As of now, only 25 states are participated. The remaining union territories and some of the states are not included in the Uday website or Uday scheme. The average value is going to be around 23.05. 12 states are lesser than the Uday, the national average. 13 states are above the national average. The lowest AT&C losses in India is Kerala, which constitutes for 8.4%. Whereas the highest contribution is for highest AT&C losses in the Jammu and Kashmir, which has a maximum value of 67 value. Of course, this will give you a clear indication that we know whenever if you save one unit of electricity at the user end, just go back. Whenever if you save 1 unit of electricity at the user end, that is almost equal to 2 units of electricity which is saved at the source end. So those points already, I mean, most of the people will know that. That is why we people are always insisting the industries and consumers, even the student community, at least save 1 unit of electricity, which is exactly equal to saving 2 units of electricity in the sense. Now coming to the industrial sector, if you want to conserve electrical energy, or if you are an auditor, and if you go to auditing field or auditing to any industry, first of all, you must know what type of industry you're going to take up. So what is the production, and what is the incoming voltage, what is the energy pattern, what are the types of energy they are using, then what is the combination of energy they are using. Sometimes they may use only electricity, sometimes they may use both electrical as well as thermal energy. In thermal, what type of fuel they are using. So all those things are very important. If it is if it is available, you can also get the production data, so that you can link the production data with your energy conservation, energy consumption pattern. Also, you can arrive the specific energy consumption. Those things we are going to discuss in the upcoming slides, and how it is going to be important for any company, any auditor, and what are the inferences we are going to get from this data. Now, the left-hand side is this electrical distribution system in an industry. It's a single line diagram. Mostly it is available in the BE website. We have an electrical power coming into the factory, assuming that this industry is an HTE supply, high tension supply. So therefore, the transformer is under their control as of Tamil Nadu state. Sometimes it may be slightly different for other state also. Please relate this information. If anything is going to be description, then automatically you can relate with your state policy. Electrical power coming inside the plant, automatically we have a main energy meter will be placed to measure the energy consumption. Now we have a transformer efficiency is going to be almost 99%. So therefore we have a little amount of scope for energy saving in the transformer, but we have, whenever the transformer is very old, and similarly the transformer will have some fault record, then automatically there is a scope for improving the efficiency, and similarly for energy conservation also. Now from the transformer, we have throughout the entire system, we have a distribution. So we have a main panel, then we have a sub panels. So from the sub panel, it will be given to each individual loads like fan, motor, pump, compressor, and all those things. So throughout the entire transmission line, the distribution loss is estimated between 4 to 8%, which is lower, which should be lower. We should make lower at of the distribution losses. Then we have a motor. Almost motor efficiency is going to be playing between 85% and 96% if they do not have any fault records, or if they are new to the industry. If it is an old motor rewinded for so many times, then automatically efficiency is a question mark. I think those points already Sri JS discussed in the previous session. But it is a right time to check each and every point, which may be sometimes important, which may be sometimes critical also. Now you can see there is a C. C is a capacitor. Capacitor is connected in the main MV panel. Capacitor is connected in the individual motor side and individual load side. Capacitor is also connected at the sub-synchronous sub-distribution panel also. So it is a right time to justify ourselves where we have to fix the capacitors. Most of the industries are mainly concentrating to compensate the power factor at the supply side, rather they are not going to concentrate on the distribution side. We will talk about what is why it is going to be connected in a different way or scattered way, and what are the advantages of having this one and also disadvantage. Now, very important point is you have a check meter always connected with the tri-vector meter. Check meter also one of the important meter. Most of the industries will have a check meter. Check meter will also one of the meter to be correlate your readings taken by the main meter. Of course, the main meter reading will be only considered for the billing, but check meter reading will also take into account if you have any discrepancy in the billing system. So apart from that, we have a panel board meter. Most of the industries will have their own panel board meter. And top companies or even most of the companies are measuring the panel board meter at regular interval, and they will also correlate at the same time. They will also correlate the reading available in the main meter. So if the difference between the main meter and the panel board meter is the energy consumed by the transformer, or ultimately you can say it is a transformer loss. So if you estimate the transformer loss for even old transformer, even if it is a new transformer, then automatically we can come to a conclusion that whether we have to change the transformer from older to newer version. If it is a newer version, means then automatically you can check whether the promised energy loss at a different load condition can also ensure. So that is a good idea. You have to check whether your equipments are properly working or as per the design it is working or not. So that is why we insist to take the readings at panel board side and secondary side and similarly primary side at a regular interval simultaneously, so that we can automatically estimate the transformer losses. And this is going to be slightly different for the LT industries, as most of the people will know that LT and ST industries depends on the sanction demand. And the LT industries, the transformer is not in their control. It is a common transformer will be feeding to all the nearby industries, even some household application also. So therefore, the upper portion is not concerned with the LT industries, whereas for HT industries everything will be considered into account. Now there are scope for all the type, all the equipments. We have a scope. We can have a scope for energy conservation, the transformer, capacitor panels, electrical network, motor and pump system, compressor, and other equipments. So if you open your eyes when you want to conserve your energy, then automatically there are a lot of scopes are available. Even most of the veterans will says that there is always a scope for improvement. So you will always see where the scope for the energy conservation proposals. And similarly, you always think to have what is the design value, what is the operating value. So if you have a design value and similarly you have an operating value, then if you compare the operating value with the design value, then automatically you can come to a conclusion that what are the area you can able to improve it. And this is the right time to check whether your transformer losses is going to be in the control value or not control, because the pandemic situation will lead to the more amount of time for the maintenance people to take the reading of the transformer side, primary side as well as secondary side. Now, some of the industries we visited and we chart out what are the major electrical issues faced by the industries. Not only the industries, even for residential application also we have some prominent electrical issues will be keep on available in the industries. Again, I told you it is not available for all the industries. It is not applicable for all the industries, and similarly for not for all. I mean, all the type of problems will not be occurring for one particular industries. The first one is going to be in power factor penalty. As I don't know whether the other state people are available and they have a power factor penalty. In Tamil Nadu and most of the states will have a power factor penalty if the power factor is not maintained. A respective value, then automatically the penalties, the utility discount companies will penalize you. Then other penalties also available like excess demand penalty, harmonic penalty, some other penalties are also, I mean, late fee penalty. So those things are also available. Then we have a motor coil failure. Sometimes it is repeated. So in one particular motor, it is keep on the coil failure will be always available. Or sometimes it is a group of in a particular department, the motor coil failure is inevitable. Then repeated fuse failure. Again, it is one particular phase. The fuse failure is going to be predominant, or sometimes multiple phase also. Then we have a voltage flickering. This is a common issue whenever if you have an electrical drives, whenever you have an electronic control equipment, then connected to a main power line, automatically the voltage flickering will be always available. Keep remember that it is continuous sometimes, or sometimes heavy load can be turned on and turn off time, the voltage flickering is available. Then improper equipment and system earthing, and that may lead to that may lead to have an leakage current and similarly electrical shock. Then excessive heat experience in the cables, cable joint devices, and even systems, and that can be easily find out with the help of an thermal imager or the thermal gun, and automatically we can able to rectify it. Even we have a heat in the system that may also lead to an energy loss. Then sometimes you can have a spark and corrosion in the cable joint and unwanted noise in the motor and any abnormalities in the systems. Now, I told you in the very few slides back, if you enter into a company, automatically you have to first of all, what is the energy mix they are using? Identify the energy usage in the industry. Sometimes the the industry may have only electrical, or sometimes may have an wood and thermal and as well as electrical. Even if it is a thermal means, automatically they may have a different type of fuels. They may use wood or biomass, pellets and sawdust, coal, again pet coke, so something like that. Similarly for furnace, again they may use the thermal and electrical type of energy. Even in our HVAC system, we can have a vapor absorbance system where we can use an waste heat as an input for the system to be for HVAC applications. So first of all, you must understand what type of industry you're going to do it, and what are the type of energy they are using it, what are the type of energy carriers they are using it, and which is going to be dominant one. Sometimes electrical is going to be higher than compared to the thermal. Sometimes thermal is going to be higher than compared to the electrical. So therefore, based on that, you have to search for your energy conservation proposals. Otherwise, you will get it. But only thing is the management of the industry will look into more energy conservation proposal. Only they have a higher amount of energy conservation. Now, electrical billing is the first important point. Always you should look. So from the electricity billing, you can able to find out a lot of information. Like what they are using, and what is their minimum value, what is their maximum value, and all those things they have. It is available in the electricity billing itself. Now see, the electricity billing, again, I'm told you it is going to be changing from one state to another state. I have 2-3 state bills are available with me, but as a presenter, I'm belonging to Tamil Nadu, so therefore I'm just representing some 2-3 basic electricity billing system applicable to Tamil Nadu, and automatically you can relate this information to your own system, your own state, and you can relate this information to your own industry. Basically, we have two type of consumers. One is an LT consumer and an HT consumer. There are two different categories based on the sanction demand. So in Tamil Nadu, we have a maximum of 150 HP and less than, up to 150 HP or 112 kilowatt are categorized as an LT consumers, and more than 150 HP are they are categorized as a high tension. Of course, if the industries are, if the industry have a load of 63 kilowatt or 63 kVA itself, it is eligible to go for an HT, or they can go for an LT itself. So eligibility for the HT is starting from 63, but LT is going to be up to 112 kilowatt or 150 HP in Tamil Nadu. Of course, recently they are they changed this to 200 HP, but there is a small some amount of deviation will be available. So therefore, most of the industries are not ready to shift from 150 HP to 200. So in HT industries, again, the electrical billing is going to be different. It's going to be a KVA billing as well as kWh billing, but only in Tamil Nadu. I know in Maharashtra you are going for you already went for kVah billing. So therefore, you should maintain the power factor near to unity, so that it will be very beneficial for the industry to maintain the total bill at a very close to or to the satisfactory level. But most of the states in India, most particularly Tamil Nadu, is still we are following KVA plus KWH. So our main part is KWH because of the based on the consumption, our kilowatt hour billing is going to be applicable. Whereas KVA is going to be depends on how much amount of sanction demand they got for the industry. So it's a fixed charge, whereas this is a variable charge. So that's why I'm representing FC. It's a fixed charge. This is a variable charge. I told you that there are other charges also available. I will show you a sample bill so that you can easily understand. Now, it is like HT industries are always you should always concentrate on what type of transformer they are using, whether it's a dry type transformer or an oil filled type transformer, whether it's an openly placed or it's enclosed. Within the room, or it is applicable. And similarly, what is the level of input voltage, whether they are in the 11 kilo voltage or 22 kilo voltage or 33 kilo voltage or even higher voltages also. And similarly, you should know also from the nameplate what the output voltage. Then what the sanction demand of the particular company and what is the recorded demand for the entire 1 year, or even at least for 1 year. And if it is available for other years also, it will be very helpful to find out whether their recorded demand is going to be met with the sanction demand, and what is the gap between the sanction demand and recorded demand. Then from the electricity bill, you can easily find out what is the penalty they are paying: excess demand penalty, excess demand charge, disincentive power factor. DPF is disincentive power factor. So how much month they are paying, how much they are maintaining the power factor, why they are exceeding the demand, what is the reason, whether they are included the number of machines or not maintaining the power factor they are exceeding. So those things are available in the electricity bill. So therefore, it is very important to assess the electricity bill at least for 1 year. That will give a lot of information about their consumption pattern, particularly for the electrical consumption pattern. Now, this is a simple example of an electricity bill. So from that, you can collect all the data. Even you can prepare a questionnaire, give it to the company, and ask them to fill all the data. But even if you collect the data, if you collect the electricity bill from the company, so that the bill itself will tell you all the information about what we discussed in the previous slides. Now, this is a tea factory electricity bill, first page of a portion of the first page of the electricity bill, where the permitted demand is represented here. This company got a permitted demand or sanction demand. Sometimes it is also represented as a sanction demand. So sanction demand is going to be an 250 kVA. So therefore, we have to this company should operate within the 250 kVA only. If it is crossed beyond 250 kVA, automatically penalized for EDC penalty. And it is in the category of 1A. 1A is a representative for industries in Tamil Nadu. And the first three will give the consumption pattern based on the time of day tariff structure. Most of the states are already moving to the trivector meter, which is calibrated for TOD measurements. So for this industry, the industrial consumption charges is given, and similarly peak consumption charges could be slightly higher. Apart from the 6.335, they have a 1.227 rupees per unit is going to be in higher charges, and similarly night-hour charges we have a 5% rebate. Now, I told you in Tamil Nadu we have a two-part tariff. One is the consumption, another one this is kilowatt hour, based on the kilowatt hour, and this is the kilowatt hour charge. This is the kilowatt hour consumed. 35,608 kilowatt hour is the consumption of the particular industry for the particular month of January 2020. Now, the demand charge for this category is going to be slightly different. So for the calculation of the demand charge in Tamil Nadu, especially the tangent co is using a simple formula: 90% of the permitted demand or sanction demand, 90% of the permitted demand into multiplied by 350 rupees per kVA per month. So automatically it is 90% of 250 is and 225. 225 multiplied by 350 is the 78,750 is the fixed charge. So this is represented here. So whether the company is running or not, whether you take the production or not, whether you are alive or not, you have to fix. You have to always pay this amount without any fail. So this is a fixed charge. You have to always you have to pay, or a part of this bill it will be always available. This is the consumption charge. Now the second page says, the first page the remaining portion will include all the other parameters like the meter rate, similarly the belated charges for not charges, and whenever if you are not exceeding the demand, then automatically the excess demand charges also paid. That column is available. compensation charges for low penalty, low power factor penalty that also indicated here. I will show you some of the slides which has a higher penalty for EDC as well as low power factor. In Tamil Nadu, we do not have any harmonic charges for 11 kilo voltage and similarly 22 kilo voltage consumers, whereas it is applicable only for 33 kilo voltage consumer, and soon it will be coming to other consumer also. So I relate this information to your particular state and automatically can check it. Then we have an electricity charge 5% applicable for a simple calculation. Then this is the total amount to be paid without any delay, and we have also other charge. If you are not paying the exact amount within the due date, then automatically you can have one more penalty will be imposed. Now, in the EB bill itself, we have all the information. Suppose if the industries are purchasing the electrical power from IEX, or they are purchasing from the third party, or they are adjusting in the windmill, everything will be available in the electricity bill itself. Recently, we conducted one audit in Chennai, which has a maximum demand of 5 MVA, and 60% of the electrical power they are purchasing from IEX, 20% they are adjusting the power from windmill. So therefore, this information will be always also available in the page allotted for the HT. Now, in the same HT bill, you can see for the particular month, this is the sanction demand which is available. This is the recorded demand. So now you can see for this particular month, this company uses or reaches a maximum demand of 202.8, and it is billed for 31 days for the particular month. And similarly, 90% of 250 is going to be 225, and the rate is going to be 350. The value is going to be represented here. Now, in the last page, it will also show the overall consumption of 35,608 is the overall consumption. Each time of day, what is the consumption of the industry for the particular month also represented. So if you add from C1 to C5, the total will be equal to 35,608. Now this is the maximum value reached for kVAH and similarly RkVAH, and this is the average power factor of the industry for the particular month. So they are not there. This is the value they have for the month. Of course, I want to tell you one information that in Tamil Nadu for HT industries, the minimum power factor is going to be 0.9. For LT industries, the minimum value is going to be 0.85. So if it goes beyond, say if it goes below 0.9 and similarly 0.85, then automatically penalty will be imposed. So if it is go beyond 0.9 and 0.85 for HT and LT industries respectively, they do not offer any incentives, but penalty will be always available. And I know that there are some states they are offering still the incentive. One of such union territory is Pondicherry, where in Pondicherry, if you are maintaining the power factor more than 0.95, you will have an incentive mechanism still available in Pondicherry. Now we just move on to some of the cost saving methods, energy conservation method, and because of energy saving, we also save some amount of money, and that will also benefit for the industry as well as for the society. And what are the low cost and as well as no cost investment based energy conservation proposals, and even we can go for some cost effective based energy conservation proposal also. But most of the time, the industry will always look into the low cost and as well as no cost. Of course, getting the no cost proposal is going to be somewhat tedious. We have to inspect, we have to analyze, we have to assess more number of information so that we will get some no cost information. Sometimes the no cost information may work, or proposals may work, or sometimes may not work, or sometimes it will give a desired result. Sometimes it will give a result, but it is not actually to the desired value. So let me have one by one. We tried some of the proposals and we got some results, and those results are presented here. The first point is that this is an industry where we have a measurement of the input system. The input voltage is going to be very high. The line-to-line voltage is 447, and even it is measured at the daytime. It is around 1 p.m. So even in the daytime itself, the line-to-line voltage is going to be very higher, where the line-to-neutral voltage is going to be almost 260 or even 255 to 260. During the night time, the voltage is going to be still higher. So we got a record of 456 line-to-line voltage and line-to-neutral voltage of 265, which is a very huge voltage. Applying a higher voltage to the equipment is not a good practice, as most of the people will agree with me. 99% of the electrical equipment available in the world are voltage sensitive equipment. if you are applying voltage will be increased, then automatically something will be happen. Similarly, if it is lesser than the specified voltage, automatically something will happen. For example, if you take a simple example of a fan, if you increase the voltage, speed will be increased, and similarly, if you decrease the voltage, the speed will be decreased. Similarly for lighting also. So specified voltage should be applied. That will be good for health of the equipment. So therefore, we suggested to have a simple idea. You adjust the voltage. Of course, this industry will have a transformer, and the transformer will be also having an OLTC, on-load tap changer, RTCC. But one important point is the OLTC is not working, and it went for services for the past. During the audit time, before 6 months back, it went for rectification, problem rectification. So therefore, they bypass the OLTC and RTCC. They are operating with the normal voltage which is supplied by the supplied by the utility company. So we suggested to kindly replace or kindly retrofit, or you quickly replace your OLTC system, and you can maintain the voltage of specified limit. That will have a small saving of 0.25%. As we know that V1 by V2 will be equal to P1 by P2. So therefore, so as per this formula, if you slightly vary your voltage to the specified voltage, a minimum of 0.25% saving of your total consumption of 550 kilowatt is the maximum power consumed by the industry. So the total power consumption is going to be 1.3 for 0.25%, and for if it is running for 6,000 hours, the entire industry in a year, then automatically the overall power saving for the entire year is going to be around 8,000 kilowatt hour. And the rupees per kilowatt hour for the industry is going to be around 7 rupees 65 paise. Even the amount is going to be very small. Even the unit saving is going to be very small. But you can see in terms of financial saving is going to be around 63,000 rupees. So maintaining the proper voltage will lead to even have an idea to conserve the energy. Also, it will be more beneficial for the equipment. Now, this is a recent study we conducted in an LT industry, where this LT industry is a small garment unit having a maximum capacity of 112 kilowatt. Sanjay sir, my voice is clear, sir? Hello, sir?
Yes, very much clear, sir. Very much clear. Everything is fine, sir.
Clear. No problem.
Oh, okay, sir.
No issue, sir. Smoothly going.
Okay.
Please carry on.
Okay. Now, this is the garment industry where we recently conducted, 3 months back, we conducted the study. This garment industry where they have of course, this is an LT industry. So so the transformer which is not in their control, anyway, the transformer supplying to this industry is very near to the company, and it is also supplying to the nearby company as well as one agricultural load from the same transformer. So we conducted the study at the input of the transformer, and we found that the input of the transformer at the morning time is going to be around the 360 to 380 line-to-line voltage. So this company will have an experience and very huge amount of voltage fluctuation during the daytime and during the night time. So therefore, they installed a 200 kVA servo stabilizer, oil-cooled servo stabilizer, to arrest the voltage fluctuation, to keep their voltage constant and keep their equipment under safe mode of operation. But during our measurement, we found that the input voltage is going to be higher. That is not a problem. But see the output of the servo stabilizer. So output of the servo stabilizer, as you know that the servo stabilizer to maintain the constant voltage at the desired level, desired set level. Now this is the voltage we measured at the servo stabilizer throughout nearly for 1 hour. More than 1 hour we measured, but I'm just giving only half an hour slot here. Now the line voltage of all the phases are not equal. Even it will be reflected in throughout the entire day. R phase will have a higher voltage than compared to the Y phase and B phase. And we thought that initially at the input side is going to be very higher. So at the load side, it may be, sir, it may be lower. But when we taking the readings at each and every point, we found that the R phase voltage is still higher than compared to the Y phase voltage and B phase voltage. And we came to know that they had some rectification problem in the transformer. So therefore, we insisted the company to check to check with an OEM and correct the voltage, because one phase is going to be very higher voltage than compared to the other 2 phases. This may be so many problems. There may be a problem of that particular phase wiring crimping system or loose connection. Even there is a control system, a control mechanism to adjust the voltage. There may be a slightly failure in the control system, or even some contact which is going to be applicable for the variac and all those things. So we insisting the company to check with an OEM, and immediately they arrested the system, and we ensured that there's 0.5% of saving for the overall percentage, but they got 0.22% saving because of that voltage, and we recently got it, and next week I'm going to take the reading, and if possible I can also present the reading in the next presentation. Now, sometimes you may have a high cost information or high cost investment also. I told you the transformer replacement is a very bigger offer. Sometimes the company may not interest to change the transformer, but we got some experience to change the transformer by taking the readings itself. So that's why as an energy engineer, as an auditor, we should also look for the low cost proposal as well as high cost proposal. Let the management will decide whether they go for a low cost investment or high cost investment. As we know that the transformer and the basic things of the transformer, the loading percentage of the transformer is very important. Often you have to load the transformer at 50%, which will be an economical for the transformer losses. And you can see this graph from the transformer manufacturers itself, or you can download from the respective website to get the loading percentage losses incurred in the transformer, and also the right side will give the individual losses for the different rating of the capacity, which is available in the series. Now, this is a nameplate of IS 1180 transformer, energy efficiency transformer, where we have 3 types of levels are available: level 1, level 2, level 3. And based on the level, also the individual losses will be also vary. And similarly, the pricing of the transformer is also vary. So let us assume that this is the 630 kVA transformer, and the old transformer does not have these details. That's a very important point. So old transformer does not have this IS standard. Of course, they have an IS standard different value, but it's not energy efficient standards. And more particularly, IS 1180 based transformers will have a losses indication also represented in the nameplate itself. Now, if you are operating the transformer at 50% loss, then 50% loading condition, then automatically the self loss of the transformer is going to be 2 kilowatt. Suppose if you increase the transformer loading near to 100%, then the transformer losses, the self loss of the transformer is going to be almost 6 kilowatt. That's why I told you, when you increase the loading percentage, then automatically the self loss of the transformer is also increased. So it is advisable to operate your transformer nearly to 40 to 60%, which will consume less amount of energy for the transformer. So that also you have to propose to the management. So based on that, we recommend to the company to replace the transformer. So the self loss estimated for the old transformer, which is not taken as of now. So that is why I told you in the very first slide itself, taking the reading at the HT side, taking the reading at the LT side, compare the values and assess what is the amount of transformer losses every day, and it can be throughout every month, every week, every month, every year. So automatically you can give enough data to your company such that this is the amount of energy loss because of the old transformer, and you can straight away replace the old transformer with the new transformer, either buyback offer or whatever may be. Then automatically you can come to a simple conclusion what is the payback period of the particular proposal. So based on that, we gave the proposal, even though the payback period is going to be very long, but the management will decide whether they go for an energy efficient transformer or not. Now the next utility equipment is an electrical motor. Of course, I don't want to take more amount of information because it is not appropriate to explain the more amount of information, because already you discussed the same point where what Sri JS sir already gave a lot of information. He is the veteran in the field of electrical motor, selection of motor and all those things. But we have a small amount of study conducted during our energy auditing along with Mr. Ashok sir, and he's going to explain the remaining things in the tomorrow. Whenever if you talk about the electrical motor, most of the people will go for an how to conserve electrical energy in the motor. Then immediately they told that we have to replace the old motor with an energy efficient motor. Yes, that's a good idea. That's a good idea. But apart from that, we have one more idea, sir. If you connect a variable frequency drive or variable speed drive wherever if it is possible, then that also saves energy. I think this point is going to be somewhat contradictory. Retrofitting the VFD to the existing motor, applicable motor, for example, if it is a compressor motor or it's a blower, sometimes it may give a good result. Sometimes it may not give. It would also give a negative result also. So care must be taken to whether you want to retrofit the VFD in an existing motor, existing blower or compressor motor, so that you will get the proper benefit or not. Then the third point is best operating practices for the motor. So I think most of the people will always be concentrating on the best operating practices in the motor. So again, I'm going to slightly touch upon the three important points in a little bit. Now you know that the motor output power, the mechanical output power, can be transmitted to the machine with the help of an proper arrangements. Either it can be a chain or belt and pulley arrangement. Again, it's going to be a flat and V-belt pulley, or sometimes it's a direct coupled also. In AGQs and all those things, it is direct coupled. Nowadays, the direct coupling is available. Even sometimes AGQ will have an VFD connected and belt and pulley drive also available. Then we have a variable speed drive and variable frequency drive. Then a simple study which will show you the slippage losses available in the belt and pulley. Most of the time, the slippage losses is going to be not addressed, but in some of the industries are regularly taking the slippage losses at regular interval. Even sometimes some of the top companies are taking the slippage losses for the motor, which is connected to the machine with the help of a belt and pulley arrangement at a regular interval of 1 week or even 10 days or even 15 days. And they will notice what is the percentage slippage losses, and if it is deviating from their set value, then automatically they will take the corrective actions. Now this slide will show you a simple example. It's not a case study, it's an example where I'm taking a 22 kilowatt motor of 80% loading condition. The speed is going to be 1480 RPM, and the pulley diameter is going to be an X meter. So I'm not mentioning an actual value, it's a X meter. Three pulley and 3 belt V-type pulley, and a constant supply voltage will be applied. Now the same motor is connected to the machine where the pulley diameter is at 2x and the ideal speed is going to be 740, because the diameter of the pulley is double, so therefore the speed will be reduced. So it is a 1480 divided by 2 is going to be 740 RPM. Now assuming that this motor is running for 20 hours per day and 300 days per year, and if the slippage between the motor and belt is going to be 0%, then there is no losses in the system. Suppose if there is if the 1% slippage persists in the system, then automatically the motor speed will not change because I'm applying a constant voltage here. That's why I mentioned it. But whereas the motor, the machine speed will be dropped by 1%. So 1% is 7.4 RPM. So therefore, the new RPM for the machine is 732.6. 7.4 RPM revolution per minute multiplied by 20 hours multiplied by 300 days is the overall revolution loss in the system. So it is an 8,880 in a day, and similarly 26.67 lakh revolution in an annum. Suppose if the percentage slippage is increased to 5%, then it is going to be around 1.33 crore, and similarly it's going to be 2.66 crore. Suppose if you have a 10% loss. Now you can see the speed in reduction of the speed will always reduce your productivity. So that is the point. Always we will keep remember. And I will show small study be conducted in a mill in the upcoming slides. And normally, most of the industries are maintaining 1% slippage at all the time, and they have to maintain between 1% to 2%. If it is going to be beyond that one, automatically they go for changes. And this is the recent type of goggle belt which is going to be newer type. And these are some of the pictures which we taken during the tension of the belt. When you press the belt of all the belt, then automatically you can see there is huge gap always available. And it's a best practice to maintain. That the top portion of the belt, what you're going to push it, is going to be almost equal to the bottom portion. There should not be a gap, so that the percentage slippage is going to be 1%. It's a thumb rule, but not an exact value. But always you have to measure the speed of the motor as well as machine at a regular interval, and you can maintain it. And this will be this is a clear indication that the belt is slightly. I mean, it is not in the proper way. Similarly, fitting of the belt, you can also see the belt, the transmission of the mechanical power is going to be taken place in the side of the belt, not on the top, and similarly on the bottom. So your proper placement of the belt is also very important. See in this figure, in the middle of the belt, and similarly in the last belt, and similarly the first belt, some portion is going to be completely buried, some portion is going to be slightly taken upside, so it is not properly placed. So therefore, because of that one, automatically one particular belt or two belt or one portion of the belt will be getting overloaded. So automatically that belt will be quickly damaged than compared to the other one. Something similar to your vehicle tires, two-wheeler and four-wheel tires. So, sometimes you can see that all the four tires are not properly wear and tear, not happen in the same way. So based on your driving, based on the road condition, based on your applying the braking, and all those things will be a matter of fact. And see this one, the belt is completely buried inside the belt. And some of the time you can have a different type of pulleys not matching with the motor and machines, even they are running within different configurations. That also will lead to a high amount of power, because the weight on the pulley and weight on the machine pulley and motor pulley and will be always on the motor side. So automatically, in order to have an excess amount of weight will be applied, then automatically the motor will take in huge amount of current to drive this. Now, some of the best practices are always available, and most of the time we will always look into the best operating practices. Whenever if you place the belt and pulley, then automatically you can ensure that the angle of the pulley and angle of the belt will be almost equal, and slightly the pulley will be above the slot, and it's not exactly on the same surface, and similarly not below. I mean, it should not bury inside the belt. Similarly, for the replacement, after 1 year and after 2 years, or after a certain bit of the time, you want to replace the belt, means automatically you will check the weight of the you will check the condition of the belt, whether a burnout has happened, or the belt. Suppose if you have a 3 belt and 3 pulley configuration, and you found that only one belt is completely damaged, then it is not a good practice to change that one belt or one particular belt. Even if you change that one particular belt, then automatically that belt will have a higher grip, and similarly again that particular belt will be overloaded. So it is the best practices to replace all the belt at a time. That is a good practice. And similarly, if you change the belt at the same time, you can also change the pulley and see the condition of the pulley. And it is better to change the pulley also, because that also gives you a small amount of saving. As you know that whenever it is keep on loading, then automatically the pulley also get vibrating, and similarly it is gets expanded. Then this is the simple case study we conducted in one floor mill, which is a wheat rolling mill of 25 HP motor, which has a 4 belt and 4 groove. And this side of table is a before study, and this is the after study. Before it take a active power of 20.24 kilowatt, and after the changing of the belt and pulley with the gargle belt, we achieve a small amount of saving of 1.34 kilowatt, which is recorded for nearly half a day. And we take around 4 trials, and I'm just only presenting the 2 trials. Of course, all the 4 trials at different interval. We conducted for the same day when the belt was replaced, and similarly 10 days back after that, then similarly 1 month after that, 3 months after that. But almost the value of the power taken by the motor is going to be still the same. So earlier it was 20.24 kilowatt. Now it is going to be 18.9 kilowatt. So we got an 1.34 kilowatt is the difference in power from the old existing belt to the new belt. Not only the kilowatt, and also it will save it will have a small reduction in the kV also. And this company will have around 35 same capacity motor for the wheat rolling application, and similarly different motor, different capacity of the motor, starting from 3.7 kilowatt to be a maximum of 37.5 kilowatt motor. Most of the motors are belt driven, so therefore we recommend this to this concept to the company. Of course, this is the change available values before, and this is the available value after. The pulley diameter is going to be diameter we are not changing, but pulley weight is going to be slightly changed because of the change in weight. Then automatically the load on the shaft will be get reduced. So because of that one, the current and power will be get reduced. Of course, the motor speed will be also measured, and machine speed will be slightly improved. Because of that one, we have an improvement of productivity also. So earlier case we got an 23.1 kg per minute of the wheat will be coming out of the machine. So after replacing the new belt and adjusting the percentage of the slippage from 4.5% to 1.7%, the productivity also improved from 23.5 kg to 25.1 kg. So that also per minute, it's going to be per minute. So that also another added advantage for the company by saving the energy as well as increasing the productivity. Now, as most of the people and you can see the I don't know whether the Dr. Nagesh Kumar sir told this information or not, and of course he will always give a very good point that please keep remember whether the VFD is required or not for any blower application. Similarly for the compressor application. Sometimes VFD will give a desired result. Sometimes it may not give a desired result. Even if they are not giving the desired result, it will act as a load. So therefore, care must be taken. So need for the VFD is basically depends on the what type of load and what is the purpose of putting the VFD. So therefore, I'm just giving a two simple example what we propose to industry. This is the tea industry where drying operation is the diagram of the tea industry, and this is the drying operation of the the photograph of the dryer bed drying operation where they are using both electrical as well as thermal. So here this is the bed. This is the bed which is available here. So they will put the wood or briquette or pellet sometimes also, and they have an ID pan which is available there, and the air will be sucked here and it will be passing through the pan. So whenever the air is passing through, automatically it gets heated up, and there is a heat bank available here, both the sides. Both the sides, the heat bank available. So hot air will be going in top portion. So automatically it will be going the through the heat bank. It will be moving to the top portions. Now the top portion is going to be very hollow. So backside of the stove, automatically they have a 25 kilowatt or 30 kilowatt capacity blower motor. So that blower motor will suck the hot air, will be passing through the chamber, tea drying chamber, and the hot air will be controlled by the flow of the hot air will be controlled by a damper circuit. And I'm just showing the damper is going to be almost open. This is for a photography, but this is the case. Normally, the damper position will be adjusted based on the temperature which is going to be required by the for drying application. Again, I told you the tea industries are mostly in the hilly areas, so therefore the temperature is going to be keep on varying during all the day, and similarly for the season it is going to be keep on varying. So based on the ambient temperature, based on the tea drying process, they will change the temperature, the damper to control the flow of the hot air. So mostly it is basic between 65 to 55%. So damper is that means damper is open 55% means it is close to 45%. That means the motor is keep on running to produce the enough amount of air, but you are not allowing the air. You are passing only 55% of the air to the system. The remaining 40% you stopped here. This is the most of the cases the tea industries are having. So we and the tea drying temperature should be between 130 to 150, because we should also know what is the practical difficulty of the industry, what is the production difficulty of the industry also. When the tea temperature is going to be beyond 150 degree, then automatically tea will be roasted. So automatically the smell will come, color will become black. So nobody will buy it. Even if you pack the tea, automatically within 1 or 2 months it will get a black mark, or you will get a feedback that your tea was completely dry. Similarly, if the temperature is going to be less than 130 degree, then automatically you see that there is a wetness is available in the tea. So within 1 month, the fungal will form. So most of the cases, it is an export order. So even if you produce the tea today and it will be open 1 month back or even 50 days back or 2 months back in the consumer side. So when the temperature is going to be lower, there is a problem. It is higher, there is also a problem. So therefore, we must maintain the temperature of 130 to 150 degree. This is the required temperature. Now, these are all the factors, significantly affecting factors. We listed with the help of the investigation of the things. We listed some of the significant factors, and also we suggested to change not a change. We recommended to put in a variable frequency drive for this motor, for the blower. And you remove the blower, remove the damper. So that will be a good idea for that one. So how much amount, and moreover, this VFD is going to be in closed loop only, because you always sense the temperature, and based on the temperature only the speed of the motor will be keep on changing. So you yourself is need not to change it. If it's an open loop type, then there is no need for go for an VFD. So it should be a closed loop type, sensing the temperature of sensing the flow of the blower, sensing the temperature of the blower. So based on that, the feedback will be given to the motor. So the feedback given to the motor with the help of an VFD, then automatically the speed of the VFD is going to be an inevitable one. Now, so when you retrofit with an existing motor, existing blower with a VFD, a closed loop VFD, then there is a two benefits are available. Number one, you can also save the wood also save. And we are expressing that it's going to be 4% wood saving, and also we have a saving of 20% of the energy consumption. So put together, there's a saving of almost 2 lakh rupees, and the retrofitting arrangement will be cost around for 2.5 lakh rupees. And this was implemented as a pilot in one industry, and they got around 2.5% wood saving and 12% of the 12% of the electrical saving for the trial basis. Of course, our desired value is not met because of some other reasons, but they're trying to get this value. Apart from that, you can also get an indirect benefit like good quality of the tree in terms of color, blend, smell, and life. So that is also ensured. So that is why we require, whether the VFD is required or not, that you have to analyze, then you have to suggest. This is another case study where we conducted in a thermal spraying machine, which is manufacturing the MPP capacitor for a single phase and 3-phase motor. And there's a equipment called thermal spray machine. So that machine is consuming more amount of power from the more amount of air from the compressor. So they have a compressor setting of 2 different values. When the thermal spray machine is on, the compressor setting is going to be different. When the thermal spray is off, the compressor setting is going to be different. So they have a compressor of a screw compressor with VFD. So by procuring itself, they got a screw compressor with VFD. Somebody told that VFD will save energy, so therefore they buy the screw compressor with VFD. And almost the companies are running for 12 hours. The capacity of the motor and all the values are represented here. This is the setting, the pressure setting for the both normal operation, similarly for a sprayer operation. Now this is the recording taken in the input side of the motor. This is the current value. Of course, the power also changes. So zone 1. So between the zone 1, only the normal operation will be taken place. There is no. The thermal spray machine is off. You can see a huge amount of fluctuation is going to be always available between this one. Number 1. Number 2, when the thermal spray machine on at this point, then automatically it stabilizes. So we found that why this is happening, and similarly when the thermal spray machine off, then we take a recording and we found that the compressor itself has a setting up when the air is not used by the company or for the product application, it will go to the standby mode. The motor will be turned off. So this is the profile we got it. So we have some doubt that whether the VFD is required for this application or not, because the motor itself is going to be turned off when the air is not used in the system. Then what is the need for the VFD in this case? So therefore we request the company to investigate whether VFD is required or not, or you are having a higher capacity of the machine where you have a VFD application. So again I told you, you have to inspect whether VFD is not required or not. I think Nagesh Kumar sir always told you that VFD is not a magic box. It will not give you a saving for all the time. It will give saving for one application, but it will not give a saving for the other applications. So therefore, requirement is going to be properly analyzed. Then only you can suggest for retrofitting the VFD, or buying the new equipment with the VFD is again based on your requirement and based on your operating conditions. So that's the point I want to tell you. Then high cost investment, I think mostly this point already Sri Jayes taken in the morning, I think so. Suppose I want to change the motor from energy efficient motor, older motor to the energy efficient motor, and what may be the saving, and how to project with the to the management with the help of a simple study where I have an 18.5 kilowatt 25 HP motor running for this RPM, and this is a 6,000 RPM, say 6,000 hours. It is a running, and this is the nameplate detail, and the date of service, the date where the motor was installed is exactly 10 years back, and it has a past history of 5 times it is rewinded, and 1 time it has a bearing fault. Now, what is the issue with the motor? Assuming that the motor is having an excess heat and similarly running during the running, it generates noise and similarly vibration. Now you want to replace the motor, or you are going to suggest to replace the motor with an E3 motor having an efficiency of 92.6%. So therefore, you can put a simple table such that what is the power taken by the motor, and what is the present nameplate power, and what is the power taken by the motor. Assuming that you have an 85% efficiency, it's a nameplate efficiency, but 5 times rewinded. So therefore, I'm taking 5% lesser value, because even for one rewinding, the efficiency will be dropped. I'm taking a very least value of 1%. So 5% is the efficiency loss. So it's an 80%. So the power input is going to be 23.13. Now the new motor is taking 20 kilowatt. Now the difference is going to be 3.3 kilowatt. The operating hour is going to be 6,000 hours, and then energy consumed is going to be 18,750. The difference, if the kilowatt hour is going to be 7, then automatically the energy loss is going to be 1.3. The same branded motor or even higher branded motor, including the transportation cost, is going to be almost 1 lakh rupees, maybe around 1 to 1.5 lakhs. And you can see this is going to be almost 1 year, I think so. And you can see this is going to be an almost energy. This process is called as an energy efficiency to replacing the same existing facility to another facility. You can also extend the same concept to all the old motor with the help of a program called NMRP. You can see this information in the EESL website, where they are implementing so many schemes. One of the schemes is a national motor replacement program, and the benefit of the program, how to register and everything. All the values are given in the EESL website. Now the capacitor, yes sir, anything to be discussed? I think some. Hello. Sanjay sir?
Yes, sir.
Sanjay sir, can I continue, sir?
Yes, sir.
Everything is fine, sir. Please proceed.
Okay,
You can continue for another 10 minutes. No issue, sir.
Okay. Yes.
Huh?
Okay,
yes. Please.
So the another one is a capacitor bank. As most of the time we know that the capacitor bank will also invite penalty, and this is the primary slide, how to maintain the kilowatt and kVA and all those things. And again, it is going to be, if you are not maintaining the power factor, and if the power factor is going to be low, then automatically your kVA requirement and your capacity of the loading will be an impact factor. If it is boosted from 0.7 to 0.9, then automatically I can increase my loading capacity of my primary equipment from 0% to 22%. Now, where I have to place the capacitance? What is the ideal place to place the capacitance? This is the flow chart will be always represented by any BE people, such that you can place your capacitor very near to the equipment. This is the first one. This is the individual compensation. And similarly, the difference in value will be compensated with the help of an SSB level, as well as a group compensation. And again, the difference between all the SSB will be compensated at the central point where your APFC is going to be placed. So if you are doing like that, two benefits are there. Of course, a lot of benefits are there, but only two. I just want to mention only two advantage. Number one, if you place the capacitor, then the voltage distribution between the first point to the end point will be almost improved. So your motor will get almost same voltage what the supply voltage will be available. Number one. Number two, the distribution losses will be also get reduced at number two. Number three, your capacity of the APFC also get reduced, because you are compensating the capacitance value, reactive power, the load itself. So therefore, your initial cost of the APFC will also get reduced. So your footprint and everything is going to be an advantageous. And this is the simple study we taken in an STP reactor motor with and without capacitance. I do not have the power value, but I'm just showing the current and voltage value. So it is an I think it's an 11 kilowatt or 15 kilowatt motor. I don't know exactly, but without capacitor and with capacitors. So this motor will consume an current of nearly 20 ampere per phase, and the voltage is going to be different. But we included a 5 kVA stability capacitor at the motor. You can see the voltage is going to be improved, and almost it's going to be equal, and the current is also reduced to 3 ampere. Now the current reduction will also emphasize the distribution line current. So the distribution line current reduction also have a small amount of saving in the distribution losses, not a very bigger amount, because we know that the current is going to be taken care of by the cables, and cable will have a resistance. So 3 into I square into R into operating hour, that much amount of small saving will be also ensured. So that's why we are insisting to put the proper values. Now this is a complete energy consumption pattern of an electrical energy consumption pattern of an industry recently conducted study, where the sanction demand of the company is 180 kilowatt, 180 kVA, 180 kVA. It's a HT industry. Now you can see the recorded demand. Recorded demand is going to be almost higher, and the percentage recorded demand by the value is going to be almost more than 100%. So because of the more than 100%, it invites penalty, EDC penalty. And also they are not maintaining the power factor, because it's a HT industry. They have to maintain 0.9 power factor. Some of the month only they are having a 0.9, but the remaining period is going to be almost lesser value. So because of that one, they invited the disincentive power factor also. Now you can see the total EDC value. It is going to be around 5 lakh rupees, and this is the DPF value is going to be around 7 lakh rupees. 12 lakh rupees is the penalty paid by the company in a year. Suppose, and similarly, the fixed cost paid by the company, and as per the demand, if they are maintaining within the limit, then automatically this itself having almost 2 lakh rupees is the difference. Now overall it is going to be around 12 to 14 lakh rupees is the difference between the excessively paid by the company for 1 year. Now if the power factor is maintained 0.99 as a desired power factor, then the new value of the fixed cost and new value of the EDC is going to be available here. Now what is the reason for not maintaining the power factor? Now this company will have an APFC, along with an APFC they have a 50 kVA fixed capacitor also. Now this is the design, the specification of the capacitors. 100 kVA capacitor is a single CT configuration, so it is located in the B phase itself. Oh, okay, now it's an 8-stage configuration. Now all the stages are represented here. Apart from that, they have a 25 kVA 2 numbers fixed capacitors. So we take the during the auditing, we turn on and turn off the capacitor, and we what is the power injected, kVA injected, and similarly what is the current taken by the capacitors. So we found that during the audit time, only these capacitors are turned on. Almost 17 kVA is the turn on. Apart from 100 kVA, only 79 kVA APFC will be on the line. Again, I told you, but the requirement is different. Now, the first 20 kVA, Y phase does not have any current because some fault is occurred. So therefore, this is not come into line. But keep remember that some of the capacitors are also on, but the light is not on. See, this is on. 20 kVA is on, but the light is not. This is because of the fault in the light system. Even though the 100 kVA, out of 100 kVA, only 79 kVA is turned on, but the requirement for the power factor at the supply side is going to be 0.94. Still reactive power is available to compensate. So this is because of the problem in the capacitor panel, problem in the sensing circuit, and the problem in the faulty capacitors also. So if it is corrected, if the capacitor bank was corrected with the help of an changing the single CT to 3 CT configuration, and you can check all the values and replace all the old capacitors and similarly inefficient capacitors into new capacitors, then automatically they can able to reduce the penalty itself from 10 lakh to 9.33 lakhs, and the cost is going to be represented here. Now placing the capacitors also very important, whether you can go for a standard duty or heavy duty or ultra heavy duty, that also makes sense. So what type of application is required? So based on that, we have to select the capacitors. So we did one company during the on-off testing of an APFC. We found that when the capacitor is off, the current harmonic will be reduced. Whereas when it is on, the capacitor bank is 211.3 kVA overall kVA. When the capacitor bank is on, the total TST current TST is going to be increased. So that means it is injecting the current harmonic. So therefore, we recommend, this is the 33 kilovoltage, 22 kilovoltage company. Though they are not inviting the penalty for maintaining the TST, but we insisting to convert the conventional APFC into a detuned filter. So that will also take care about your APF's power factor. Also, it will take care about your harmonics things. Then finally, we come to the point of analyzing the electricity bill itself will have some good savings. See, I'm just showing some of the bills. LT bill will have an around power factor penalty of 31,000 rupees. But this company paid in a year, the total bill paid by the company in a year is going to be 3%. So in the 3 lakh rupees, in the 3 lakh rupees, 30%, 10% is the penalty paid by the company. And this already I show you. And this is a two different EB bill of two different tea industries. They are not having any penalty, but only thing is rupees per kilowatt hour. The total amount paid by the company, the amount consumed, the total amount consumed by the particular month. So this value divided by the kilowatt hour, that gives rupees per kilowatt hour. That means for 1 kilowatt hour, how much is the energy consumed? So that is clear. Now this company average value is going to be around 7 rupees. So for 1 kilowatt hour, this tea industry will have 7 rupees is the paid amount for the company. This is another tea industry of the same duration. See the same duration, but this kilowatt hour rupees per kilowatt hour is 6 rupees 11 paise. Now both are having different capacity. Both are having different production, different capacity of the production also. But the common connecting point is rupees per kilowatt hour. This industry will consume take only 6.11, whereas this is 6.97. Now this is more efficient than compared to the previous one. Why? Because they are maintaining this company maintaining a very good power factor and operating the load condition almost close to the sanctioned demand. Whereas here the sanctioned demand is going to be not met. Of course, 70% is the load condition, and similarly they are not maintaining the PF. That may be for having a lesser value. And we recommended to surrender. Suppose if the amount of sanction demand is not utilized by the company and they do not have any plan to expand further, then automatically we can recommend the company to surrender the KVA. Also, it will give a huge amount of saving for the company. So this is an example where the percentage loading is going to be only 32%. The sanction demand is going to be only 400, and this company do not have a plan for expansion. And initially they have an idea to expand it, but they shifted the expansion plan to some other country. So therefore they are still having 400 kVA, but we propose that to 200 kVA. So when it is changed to 200 kVA, automatically there's a change in the electricity bill because of the reduction of the fixed cost, almost around 7.5 lakh per annum. But keep remember that in Tamil Nadu, if you surrender the kVA, automatically one-time charge will be applicable to you have to pay to the utility company. It is twice the amount of the charge which is going to be for the demand. And these are all some of the condition monitoring. Of course, this is not an energy conservation method, but it is going to be condition monitoring. As you know that the thermograph is a very good tool for condition monitoring of the system. Of course, this also will have a good impact of the savings in the system. So continuously you can monitor the motor and all electrical equipment temperature, and check whether the temperature is going to be within the limit or not. And if it is going to be a very, very higher limit, then automatically based on the rule or based on the standard, you have to take the proper decision to address the problem. And similarly, it is going to be for all the cases. Even for hot oven, we can take this one and we can suggest them some insulation methods, all the motor casing and all those things. And best practices, I think JSR gave some elaborate information about the motor management plan. This is another tool, vibration techniques, vibration for all the rotating machines, not only the motor, other rotating machines. And this is the voltage drop experienced in a system. It is recorded 410 and 412 voltage in the supply power side in one particular dB. The same dB is measured at the location side. The voltage drop is going to be 400. Now the 10 to 12 voltage drop is the experienced during our measurement. And we asked the people, and they told that between the power house to the particular dB, throughout the entire cable, there was an in 8 different places they have an joints because of the cable damage. They have a joint. So whenever if you join the cable, automatically resistance will be increased. That will reduce the voltage drop and similarly lead to a power loss. And finally, we can have a specific energy consumption. It is going to be also one of the important tool where I can put all the cost of the energy. So, for example, in a tea industry, I have a wood consumption, electricity consumption, wood cost, and electricity cost, and put the total cost. And I can map with the production, the made tea. So this is the total cost, 28,000 rupees, and this is the made tea. So for production of 1 kg of tea, how much is the cost? Yes, sir. Hello.
Yes, sir.
Sorry, 2-3 slides, sir. I can finish.
Okay.
So throughout the entire area, you have to put the same thing, and you can find whether the value is going to be equal or not. But sometimes it is not equal, and we have to find why it is not equal. See, for 1 month it is going to be 8.81 rupees. That means for producing 1 kg of tea, July month it's going to be 8 rupees 81 paise. Whereas the January month of 18, the value is going to be almost 21 rupees. Then there are so many reasons are available. There may be a wood price variation, higher consumption in the wood in the winter season, and similarly quality of the leaf is also very important. So that is why I told you you have to identify which industry you are going and what is the production process. Then only we can come to a conclusion whether saving is possible or not. Similarly, moisture content of the leaf, controlled withering operation, and fixed cost of the electricity. So those are all the important factors, and we can insisting that during small variation in all the important significant parameters, that will make my higher consumption to a lower consumption. Even if one rupee is reduced per kg, then for 10,000 kg, it's going to be 10,000 rupees. Then automatically it is a good saving for the industry. So we have to find out what the reason for variation of the specific energy consumption, and based on that we have to suggest so many things. So apart from that, we have a lot of electrical equipments are available. Lighting is available, compressor, HVAC system. Similarly, for the lighting, we have we have an enormous studies required based on the National Building Code, and similarly for the ISHRI standards also available for lighting study. In lighting study, we normally conducted two type of study. One is an objective study with the help of a measurement, and similarly subjective study with the help of an interview or by asking some questions to the employees whether the lighting is sufficient or not, whether the daylighting is going to be sufficient or not, and we can correlate this objective study and subjective study and present to the company. And similarly for the compressor and similarly for the HVAC system, all even furnace and whatever. And these are all the advanced instrument available. And these are all the services offered by our company. As most of the cases, we are following the highest standards. And I think I'm exceeding the limit of my time, 3:30. I'm really sorry for exceeding the time. If you have any questions, please you can ask me, and if I know, I will answer, and if I don't know, I will let you know the answer in a short.
I've raised 2 points, 2 questions. Thank you very much for an excellent presentation.
Yes, sir. Yes.
I raised 2 points, sir. Can you kindly go through? Chat box it is.
One minute, sir. Well,
how the percentage? Hello.
While calculating the rupees per kilowatt, whether the amount pertaining to sanctioned load is subtracted and compared. No, sir. Actually, in an electricity bill, what is the total amount to be paid by the company? That amount divided by the unit generated, unit consumed by the company. If you reduce the yes, sir.
Sir, I would like to substantiate my question.
Yes, sir.
I am speaking from Bangalore.
Yes, sir.
We have a fixed charge for all the consumers depending upon the sanctioned load. For example, mine is 100 kilowatts. Another company is having same type of company having 120 kilowatts.
Okay.
Then the fixed charges are always levied irrespective of even 1 unit is consumed or not.
Oh, okay.
Now, I don't know about this in Tamil Nadu. That's why I'm asking whether if there is anything similar is there. If there were to be anything like that, then while comparing rupees per kilowatt hour of final bill payment, sorry, what is your calculation? I'm sorry, I'm not able to remember. Is it rupees per kilowatt hour?
Yes, sir.
Correct. So rupees per kilowatt hour final consumption that consists of all other inefficiencies in the system, excepting the constant amount which these people are charging. So if there is anything similar in the case of Tamil Nadu Electricity Board, then these two charges, that is different fixed charges, if any, is to be minus and then divided to arrive at rupees per kilowatt hour is my point.
Yes, sir. You are correct, sir. If you subtract the fixed cost, means automatically it will come to your original kilowatt hour cost. No.
What I'm telling is because somebody may be consuming at 0.87, somebody may be consuming at 0.89 power factor. Somebody may be paying excess demand charges. Somebody may be paying penalty, power factor less penalty. All that will gets built in the rupees per kilowatt. That's why I'm asking.
Yes, sir. Correct, sir. So if you subtract the value of the demand charges, then you can do the same calculation. That are also a good indication for saving the rupees per kilowatt hour. Correct, sir. Then what is your second question, sir?
One more question.
How is the percentage slip bill is converted amount in rupees?
Yeah, I saw the slide on 1%, 5%, 10% slip in the belt.
Yes, sir.
You have arrived at, let's say, 1% belt slip. How did you arrive at the cost in rupees? If it is possible, can you please put that slide?
Sir, actually, one minute, sir. I think in that slide I didn't mention anything about the amount. In 1 minute.
No, you put no savings. For example, money lost. 1% slip means how much money is lost.
No, I think I didn't mention anything about money, sir.
Okay, I'm sorry. I may have understood wrongly. Just wanted to see the slide.
This one, sir.
Belt. Slip in the belt.
one, sir.
Yes. It says, for example, 1% a slip. It says,
It's a speed losses, revolution loss,
speed
not
loss.
the money.
Okay. I think I have not understood correctly. Now I am able to understand.
It is
Speed loss. Okay.
revolution per minute, sir.
So
Revolution
lakh
per
it has come, so I thought it is rupees. Okay. I'm sorry.
okay. I'm sorry.
Right,
Yes,
right.
yes.
No
Yes.
problem.
Thank you, sir. Thank you.
Thank you very much.
Sir, in our institute,
Yes.
while connecting that connection to the laboratories, because by the 3-phase connections, all the 3 pages are connected to 2020 machines. Most of the time that machines are not working all the time. So there is a voltage unbalance. How to resolve this issue, and what are the effects of this voltage unbalance, and how to resolve it?
About the voltage unbalance, see, your supply side voltage is still correct, sir. Are you maintaining the supply side voltage correctly?
Yeah, it is correct.
Then
three phases are connected per phase. 20 machines, suppose they are connected, and only 10 machines are on. Rest 40 are not on.
Correct, sir. But it is common issue. I will tell you, sir. Actually, but if more number of single phase loads are connected in 3-phase, number one. Number two, if you have a more number of electronic component load are available, then automatically unbalance will be always created. Are you talking about the unbalance of current or unbalance of the voltage?
Both.
So unbalance of current is inevitable, sir. Only thing is, that is why we are earlier we have a 3.5 core cable. Now that was replaced by 4 core cable. Now most of the industries are having 5 core cable. R phase, Y phase, B phase have a separate cable. 2 core for the neutral, because of a higher number of harmonics are introduced, because of the higher number of drives introduced in introduction. This is for current. So you have to reduce the harmonic current by putting the harmonic filter. Then automatically this problem will be solved. This is the number one. Number two, even if you have a number of equipments are not started and turn on, your voltage drop is going to be almost small. If the wiring is going to be very pakka, and if the distance between the first supply point to the load end point does not deviating the maximum length offered by the system, then your percentage voltage drop is going to be always lesser. So it should be maintained the lower voltage, percentage voltage drop. So when the voltage is not voltage drop, and similarly the voltage between all the 3 phases are not equal, then you have to inspect whether the system is proper. I mean, whether any deviation in the loop which is connecting from the source to the load. I think you can refer IS 723 standards, code of practice for electrical wiring system, where there is a last test called voltage drop test. So in that we can take this test. Of course, it is mandatory for all the consumer to go for all the 10 tests recommended by the standards, like earth resistance test, loop impedance test, and all those things. So in that, the last test is an voltage drop test. So I think it is a right time to go for an voltage drop test simultaneously taken at the source side and load side, and you can estimate whether the voltage drop is going to be deviating from your system, and if it is deviating, then you have to find out what is the reason for that one.
Okay, sir. Thank you. Yes. Any questions? Anybody want? They can unmute, and directly they can ask questions.
So one more question in the chat box: how to calculate the cascade efficiency?
So cascade efficiency is a multiplication of all the efficiency of the system, sir. It is very simple. I will just go to the first slide. It is available in all the books itself. If I have two systems connected in series, then the efficiency of the one system multiplied by the efficiency of the second system will give the cascaded efficiency. It's a very simple calculation. So multiplying all the efficiency put together is the total efficiency. And also you can take the yes, sir.
We have to take the fractions.
Fraction multiplied by 100, that will give you a percentage efficiency, sir. When you're doing the calculation, it is going to be a fraction. That so why? Because suppose if 100 megawatt is transmitted from one point, so it's the generating station, definitely the 100 megawatt is reaching should not reach your load end, sir. It will be lesser than 100 megawatt, sir, 100 megawatt. Or if I measure what is the amount of power I received here, for example, it is a 90 megawatt. 90 megawatt divided by the overall efficiency divided by 0.9, then that will give my input power. This is something similar to your input and output of any system, sir. It should be a fraction to find the actual value. Anything, sir?
I think questions are over. Anybody want?
Okay.
They can unmute and they can ask questions. Sir, it was nice presentation.
Thank
You
you,
added
sir.
so many points in a single presentation. So many basic things have been added.
Yes.
Khade, sir?
Yes, sir. So I thank Dr. S.R. Sivarasu Sir for sharing his knowledge and experience to our participants. He discussed about scope of energy conservation in electrical utility. He also discussed different case studies of energy conservation in the electrical utility. Once again, I thank on behalf of Sharad Institute of Technology, College of Engineering for this interactive session. Thank you, sir. Thank you.
Thank you, sir. I thank the management of Sharad College of Technology, College of Engineering. Especially my special thanks to the coordinator of the program. What a nice topic he chosen. So I request all the participants, please stay on all the sessions because all the topics are very interesting. All the presenters are real experts. So therefore you can listen from them. It will be a very great knowledge sharing for you and knowledge gaining for you. So therefore, kindly utilize this opportunity to get more knowledge on energy measurement, energy conservation, and energy auditing. Thank you all. And if you have any questions, please ask me even offline also. Thank you, sir.
Even we'll collect if any questions are there and we can send to you
Yes,
on
sir.
WhatsApp
Sure,
as well
sure.
as mail. Yes.
Sure.
Yes.
Sure.
Yes. Thank you. Thanks a lot, sir. Thank you.
Thank you, sir. Thank you.